Hey folks, welcome back for another episode of Code Club. In the last episode, I shared with you a data visualization that I grabbed from Nate Silver's newsletter on Substack called the Silver Bulletin. In one of his posts on November 19th, shortly after the 2024 US election, I know perhaps this is too soon, who knows, very stressful, there was this figure that I was really entranced by. Here he looked at the national polling and actual vote data, as well as 7 so-called battleground states. These are states that tend to be close in representation of Democrats and Republicans, tend to have a decent number of electoral votes, and are the states that saw the candidates most often. I can tell you my phone was ringing off the hook. It's getting all sorts of text messages, either side wanting me to vote for them. Our mailbox was full every day with campaign literature from both candidates every day. It was really annoying. Anyway, and I should also go back and say, if you're not from the US, and maybe if you are from the US and you still don't understand our electoral system, it's based on the states, and it's based on the size of those states. So there's big states like California, New York, and Texas, but those states are also highly partisan. California and New York are very Democratic, whereas Texas is more Republican, right? Another state like Delaware, I suspect is Democratic, but it's small, so it doesn't really matter a whole lot, right? Whereas a state like Michigan, I think has 15 electoral votes, so it's a decent number of votes in the grand scheme of things. There's a total of 538, and you need 270 to win. And so these states all have about 15 to 20 electoral votes, I think, and as you can see, at the actual vote, Trump barely won all of them by a couple percentage points, right? So it's very close elections for these states. Of course, the Harris campaign was expecting to do better than they did because Michigan and Wisconsin were polling more towards her than towards Trump. Of course, the national average was leaning towards Harris, but the national average doesn't matter for anything. And perhaps Pennsylvania could have flipped towards Harris, again, based on the polls being so close. But what Nate Silver brings up in this article is that polling data consistently underestimates Trump's performance. And so again, he showed that with these 7 states. Now, there are 50 states in the United States, plus the District of Columbia, that contribute to the 538 total electoral votes. I wanted to know, if we look not just at these 7, but at all of the states and the District of Columbia, could we see the same type of underestimation of Trump's performance? And so that's what we're going to visualize in today's episode of Code Club. I have mocked up this very simple cartoon version of a plot that I want to make today with data from all of the states that we have polling data for. On the x-axis, I'm going to put the actual vote from the November election. The y-axis will put the polling data, an average of a bunch of polls. But some states get one poll, and some states get many polls. Actually, some states get no polls. And so I think the size of this plotting symbol that I'm going to use, as I've kind of illustrated here for like Michigan, I'm going to size by the number of polls, so that also a state like Alaska will be very small because it only had one poll. Of course, there's some states that had no polls. Another factor is the recency of those polls. So Michigan was getting polled like right up to the day of the election, whereas other states, the last poll may have been back in early October or maybe even September. And so I'm going to use the alpha, the transparency, to kind of indicate that we don't really trust those older data. And perhaps the newer data we could make totally opaque or solid color to indicate to the viewer of this visual that that's data that should be more trustworthy. Another thing I'm thinking about is that we have these plotting symbols, my favorite 21, which has a fill in the center and then around the border, or has a border, and that can be a separate color. And so I'm thinking to take the border color, if it's a battleground state, and maybe make it a different color to make it stand out from the non-battleground states. Of course, I expect the battleground states to have more polling data than the non-battleground states, and so maybe the size will already take care of that. Finally, the thing that's most important in the election isn't, how much you won by, but that you won the state, right? And so, and how many electoral votes are in that state. So I'm going to use a gradient, I think, to fill each of the plotting symbols by the number of electoral votes that that state had. And so, again, this is a work in progress, and we'll see how it goes. But again, if that idea that Trump was being underestimated by the polls, then I would expect that we'd see most of the data in the lower triangle of this plot. And the other reason I'm interested in doing this beyond just the battleground states is because a state like Texas that would already be pro-Trump, that data gets lost, right? Because no one looks at the results of the actual election and compares it back to the polling data because he was expected to win so handily. But if we see a bias in Michigan, I would expect to see a similar bias in Alaska or Texas or these other very conservative leaning states. And I would also expect to see it in a state like California that you would have expected to go very heavily towards Harris, right? And so I would expect this lower right triangle of the plot to be filled. Heading over to our studio here, I have assembled a CSV that I'm calling 2024 presidential data.csv. If you want to get this data as well as the code that I'm generating today, go down below here in the description for this episode. You'll see a link to a blog post where you'll be able to get the data, this 2024 presidential data CSV, as well as my code. I've already tried to kind of show you what this margins data frame looks like. I have the states as well as the national level, what Harris's average poll was, what Trump's average polling levels were, the number of polls, when the last poll was done, and then what Harris's vote was and Trump's vote were percent for that state. And then it's getting truncated here, but we also have the number of electoral votes. And actually, maybe I never use this thing, right? This data table, but you can then see the number of electoral votes. And of course, I put national at 0. And so something you'll see like Alabama, District of Columbia had no polling data. And why wouldn't there be any polling data? Because it's kind of obvious, right? So like District of Columbia, 92.5% of the people in the District of Columbia voted for Harris over Trump. Why would you need to poll that? We all know that DC is very Democratic leaning, right? Alabama is about as red as the states come, right? And so this went 2-1 to Trump. There's no need to poll that, right? So this will lead to an interesting design question when we're building our visual, is what to do with these states where we didn't have any polling data. Something else I want to call your attention to is that we have two states that don't do winner-take-all electoral votes. So like Maine, for example, they have 4 electoral votes. So they have 2 for kind of at-large across the state, and they have 2 for each of their congressional districts. And so the way they divide their electoral votes, as does Nebraska, where it's got 5 total, so 2 and 1 and 1 and 1, is that the winner of the state gets 2, and the winner then of each congressional district, 1, 2, or 3, gets that electoral vote. And so I'm splitting that apart because there's polling data for each level of this statewide as well electoral for Maine and Nebraska. And then there's also obviously the vote results for those congressional districts as well as the state. We have polling data for most of the states, and you can kind of see from some of these, like Oklahoma, again, this is a very Republican-leaning state, went over 2-1 for Trump. The last time it had a poll done was in September, like 2 months before the election, and only had 1. And so probably wouldn't trust that a whole lot. All right, so we want to visualize this data, and I have my handy-dandy picture to guide my efforts here. All right, so with margins, the first thing that we need to do is to get the difference in the percentage points of the 2 candidates. So I'm going to go ahead then and do a mutate on this to get, I'll do polling, and that's going to be Trump poll minus Harris poll, and then we'll also do actual, and so then we'll do Trump vote minus Harris vote. And if we go ahead and run these 3 lines, we're not going to see anything because it's going to go off the right side of the screen. So let's go ahead and do a select, and the columns we want are going to be state, polling, actual, end polls, last poll, and I believe we've got electoral votes. Okay. And so again, if we look at margins, we now see these columns. I'm going to go ahead and drop any row that has an NA in it because it's not going to contribute to the overall story about bias in the polling data. So I'll go ahead and do drop underscore NA. And then if we look again at margins, I then see that we have 49 rows and 6 columns. And so we're going to have potentially 49 points on our plot. All right, I'm not gonna assign this back to margins after all. Sometimes when I do that, it just kind of gets in the way. As I was showing, I want to see what the value of all this is, and so then I have to run it, and then I have to call margins, and it just makes for a headache. I can actually just pipe this directly into ggplot. So on the AES, on the x-axis, we're going to put actual. On the y-axis, we'll put polling. And then I said size will make n polls. All right, and I've got sizes, so we'll do that. Let's leave it there, and let's go ahead and do geom_point. And so that is the makings of a plot. Very cool, right? Let's go ahead then and save this to a file, because we're gonna be kind of futzing with the design of it, and it works much better to do that in the actual outputted file than doing it in this plots window. So I'll do ggsave polling bias, and we'll do width equals 5, height equals 5, and this is going to be a PNG. So we'll do .png, and so now here is our plot, right? And so one of the things that the curiosity is going to get to me that I need to know is where is the no bias line, right? And so that's going to be a 45-degree line that I had drawn in as kind of a hashed or dashed line. So we'll do a geom AB line, and we'll do slope equals 1, intercept equals 0. I'll do color equals gray, and we'll do line type equals dashed. And there you go. And sure enough, right out of the get-go, we see that it does appear that most of the points are falling below that 45-degree line, that the polls in general are underestimating Trump's performance in the election. Very cool. And we see the bigger circles are really clustered right here, right around like 0, 0, or I guess more like 0 to 10 and 0, right? And so something I'm thinking about as I look at this is that we have a lot of range here, right? And so like there's states where Trump was favored by close to 60%, right? And those aren't very big in terms of the number of polls, right? Let's go ahead and let's just sit with that for a minute. Something I'm thinking about is whether we perhaps want to bring in our axes and maybe make a value. So if we did like say like -20 to 20 or -10 to 10, that we could then say less than -10 to more than great 10, right? And so we could kind of just focus on the things that are most important, and we could then kind of put those things that were at 10 or higher on that border. Hopefully that makes sense what I'm saying. But let's go ahead and add in the alpha. So let's think about how we would do the alpha first. And so we're going to do it in terms of recency. And to my read CSV, I'm going to tell it how to read in the different columns of data, right? And so most of these look pretty good. I'm going to format that by doing call_types equals calls. And we'll do .default equals call double. So this is going to be the default format to read things in, right? Things for like Harris poll, Trump poll, N polls, Harris vote, Trump vote, and electoral votes, right? So state we want to be call character. And then last poll, we want to be call date. Yep, lowercase d. And so if we read that in like that, it is unhappy. Why are you unhappy? One or more parsing issues, call problems. So we'll say, okay, we'll go ahead and pipe this to problems. So it doesn't like my date format. There are ways to feed in the date format into call date. I'm not going to do that. I'll do a mutate on the date. So we'll go ahead and read in last poll as call character, which effectively is what it was automatically doing for us. So let's go in here and do last poll equals, and then from Lubra date, which is part of the tidyverse, we can do MDY. So it's the MDY function for month, day, year. This is the US notation on last poll. And so let's go ahead and run this and see what it looks like now. So we didn't get any errors. And so now it converts it into the ISO standard where we have 2024, so year, month, day, right? So that's great. And so then as this feeds in, we're selecting and dropping the NA. but we want to get some measure of the recency. And so let's go ahead and do a summarize to get the last, and we'll do max last poll. I wonder if that'll give us the actual last poll. So I need to remove those NAs. So we'll do na.rm equals true. And so we see that this actually is the last date. So coming back in here with last poll, I'm going to go ahead and take this then, and we'll do age. And so then we'll go ahead and do that date minus last underscore poll. So I'm curious what this is going to give us. And it's saying error caused by minus date can only subtract from date objects. So let's go ahead and make this as.date and then minus last poll. There we go. And so then it's hiding the data from us. So let's go ahead in here and add age to this whole thing. And we'll pipe this over and we'll remove that pipe. So now we get the output. Okay. And so now we're getting the age in terms of days. Cool. And so now what happens if we take this all the way through drop NA? We then, of course, drop those out, and that's great. So let's go ahead then and pipe this into ggplot, and we can then go ahead and do alpha equals age. Don't know how to automatically pick scale for object of type diff time, defaulting to continuous. So it didn't actually complain about the alpha. I thought it might. But let's go ahead and get rid of that. I think we can go ahead and make this as.numeric on the age column. Cool, that got rid of that problem. And now we've got our age scaled to the alpha. So things that are older are darker and things that are newer are lighter. And so we probably will want to fix that before too long. So we also wanted to indicate the number of electoral votes by the color. And so let's go ahead in geom_point and we'll do shape equals 21. So for now, I'm going to make the color equal black, and we'll come back to that. And the fill, we're going to make electoral votes. So we now see our number of electoral votes. The lighter things have more electoral votes. The darker things have fewer electoral votes, right? And so there's a few aesthetics here that we're going to want to change before it's all said and done. Now let's come back to this color. And I'm going to give color to be battleground. And let's go ahead and put that over separate lines. And then we're going to want to go ahead and modify what we have here further. And we'll add another column that'll say battleground. And we'll also add that to our select before I forget to do that. So go ahead and add that. And we've got battleground here. Oh, but I misspelled it differently in the different places. So I'll do that. So battleground will be if the state is in battleground states. Okay, so we need to define battleground states. And so we'll do that up here with a vector. And I will type this out and I'll be right back. All right, so here are our battleground states, and then running this through. So now I can see some of these symbols have a red circle around them, and you can kind of see down here, this bottom legend, battleground, the top is false and it's got that red color. Let's look at the output of this first part where we are reading in and processing the data. And so we can see now that we have a logical column for battleground, and Arizona is a true, and I suspect Michigan as well. So we could test it by doing state equals Michigan, and we see that that is true. That is a battleground state as it's supposed to be. So looking at the full plot, such as it is so far, we see that we have the full plot, we have all the aesthetics, but now we need to change the aesthetics to be actually aesthetic, to look good. I'm going to start, as I normally do, by cleaning up the background. I think I'm also going to make the coordinates to be equal so that, a 1 percentage point difference on the x-axis is the same as the y. And so I can do that up here, and we'll do chord equal. And then we'll also go ahead and do theme classic. So that cleans things up rather nicely. So I'm going to start with changing the color scale for the number of electoral votes. And so we'll come in here. And before I do that, I'm going to go ahead and move my points to be on top of that 45-degree line. Okay, so scale, fill, gradient. And the lower end, I will maybe make low to be white. And in my card, as I was drawing it out, I made red the full color. But red and blue are loaded, right? Because red is a symbol for Republican, blue for Democrat. And so maybe I will use dark green. All right. And so let's see what that gets us. And that didn't do at all what I thought it would do. It's going from white to blue. Oh, and it's probably because I forgot to put in high. I think dark green became the title. So that's not what we want. So we want high, the high level to be dark green. Okay. And so things are looking a bit wonky because the alpha is reverse of what it should be, right? So let's go ahead and change that. And so I think we could do scale alpha gradient. Actually, it's not popping up. So I wonder if that's a real thing. No, it's not. And so what do we have for scale alpha? Bin continuous. So maybe continuous is what we want. And so alpha transparency, not tremendously useful. I might disagree. And so continuous, we have a range of 0.1 to 1. And so I wonder if we, that's the range. I wonder if we can give values in there as well. So I think I could do scale alpha continuous, but I just had an idea. The problem is that the alpha is inversely proportional to what I want. And so I wonder if I make it negative, right? So if I map negative age to alpha, if that will get what I want. So I think that works pretty well. So the older things are more faint and the newer things are more solid. And I'm kind of noticing in here kind of the hot mess, if you will, of those battleground states, and that they look transparent, but they're clearly not. But they're low on electoral votes. And that's because we have a few states with tons of electoral votes, like this one and this one. Like this is probably Texas. This is probably California, I want to say. And so I wonder if what we might want to do is to convert electoral votes that are above a certain threshold to some other value. So let's come in here and let's do some testing. So again, if we look at our data frame, we're interested in the electoral votes. Let's go ahead and arrange negative electoral votes. And so that negative is going to make a descending sort, right? And so we have like 54, 40, 30, 28. So those are California, Texas, Florida, New York, and then Pennsylvania. So Pennsylvania is a battleground state. And so I want to leave that in. And so maybe anything over 20, I'm going to flag as being over 20, right? Or maybe over 19, right? So I will go ahead and comment out that arrange, and this pipe then will feed in here. So just to remind ourselves, this is what we had. And I think we can come into scale fill gradient then and do limits from 1 to 20. And so then you'll notice the states that were previously the solid green are now gray. And that's because an NA value gets plugged in. And so we can do NA dot value and plug in that color of dark green. And so now we see that those states are dark green. And so up here then in our legend, we're going to want that 20 then to be greater than 20. And I'm realizing as I look at this that we actually do have a 0 electoral vote. And that is the nation, right? So let's go ahead and put that down to 20. And then we'll go ahead and here and do breaks equals C 0, 5, 10, 15, 20. And the labels will do 0, 5, 10, 15, greater than 20. We now see that we've got that greater than 20. So the next thing I want to turn my attention to is the battleground states. We'll do scale color manual. and we'll have breaks of false and true, and then values. So for false, I'm going to make that NA so that there is no border color. And if it's true, for now I'm going to put in black because I don't want to have to think about what color to pick. So I'm noticing a couple things. So first, the border isn't transparent, it's gray. Maybe we can make the border white. And then for these, the battleground states, we could go ahead and make those yellow or golden. So let's go ahead and do white and gold. For whatever reason, that just seems like it kind of sapped a lot of energy out of the figure. Maybe we should make the border black or gold. So let's do black. Yeah, I think that works pretty well. So I'm not totally sure what to do with all these legends. We have 4 legends, and I'm not really keen to leave all 4 legends just because, what a pain, right? And so let's go ahead and turn our attention to the axes because I'm not sure what to do with that right now. So we'll go ahead and throw in labs, and X will do actual vote difference, and then Y will do polling difference, plus there. As I look at this, I think actually I do like having all of the data here and not censoring things that are out beyond, say, 10%. Because really the goal here is to show that there is some type of bias. And so I think I'm going to leave that, right? And maybe what we could do is have our scales go from like -30 to -50. Actually, let's figure out what the limits are. And so let's come back up here and do summarize, and we'll do min actual, min polling, and then max actual, max polling. Basically -32 for the smallest level and about 55 for the maximum. Let's work with that. So again, if we look at our plot, we go -20, 0, 20, 40. Maybe we could do 30, 15 out, right? So let's go ahead and try that. So I'll go ahead and comment this out. And then for my scale X continuous, my breaks, I'll do a seek from -30 to 45 by 15. I think that works. And we can do the same thing on the Y axis, of course. And so we'll do scale Y continuous. Now we want to indicate that the stuff to the right is Trump favored and the stuff to the left is Harris favored, right? And so maybe at the 15s, we can say Trump or Harris, right? And so we'll do that in our break. So the X, we'll do labels, and we'll do C Harris plus 30, and that needs to be in quotes. And then we'll do plus 15 plus 0, and then we'll do plus 15, and I went out to 45, so plus 30, and then Trump plus 45. And as I look at this, the more I think maybe we should do it by 20s, just because there's a lot of stuff on that axis. So let's do -20 to 40 by 10s. And we can do Harris 20, 10, 0, 10, 20, plus 30, and then plus 40. For some reason, I don't feel like we're gaining on much here. Yeah, so that didn't really help us much. So why don't I kind of reset here by turning off the scale X continuous. And actually, a lot of this is going to be clouded because we have all this legend information. I'm going to go ahead and remove the legend. So in geom point, I'll go ahead and do show.legend equals false. That gets us more space. Before I do the text on the axes, I'm going to go ahead and mess with the title. And so one thing I want to highlight is the number of states where the difference pro-Trump in the actual versus polling was greater than for Harris. So again, if we look at our data processing up here, we are getting the state, the polling, the age, the actual, the number of polls. And so what we want to know is the number of states where actual was greater than polling, right? So actual greater than polling, like for national, would mean like Trump was favored by 1.5, whereas by polling, Harris was favored by 1.2, right? So in that case, Trump was underestimated, right? And so in our mutate, let's go ahead and do Trump better, and then we'll do actual greater than polling. And then if we look at this, and actually, I think I'm actually going to end up saving this as a data frame. Let's go ahead and see the output here. We then see that we have, we didn't output it with select. So we need to include, and of course, our Trump better is off the end here. But if we go ahead and call this margins, so we could do n Trump better as equaling margins $Trump better. That gets us the column, but it's not, I think it's margins, not margin. And right, so that's gonna be a vector of trues and falses. And so then we'll say sum of that, and that is going to be 44. And so then we'll say with polling data, and we'll do length margins Trump better. And so that's 49, right? So 44 of the 49 states or electoral votes, right, within those states had better results for Trump at the election than by polling, okay? And so we're going to then feed this into the title. And to do that, we're going to use glue. So we'll do library glue. I'm also going to do library ggtext. And so then down here in labs, we'll go ahead and do title. So I'll do glue, and then I'll do in curly brace n Trump better contests Trump outperformed Harris. And I guess I need to say of, in that of W polling data contests, Trump outperformed Harris. Upset with me because I probably forgot to feed this in. So this is gonna be margins. And so then I'll feed margins into ggplot. So that's not a very satisfying title. But I think that sums it up, right? Let's go ahead and left justify that. While we're here, I'll go ahead and do theme plot.title.position equals plot. That will left justify it. And then we'll go ahead and do plot.title equals element text, face equals bold. That's good. Let's go ahead and put a subtitle in. Each plotting symbol is colored by the number electoral votes with the battleground states highlighted in a golden ring. States with more polling data have larger points, and those with older data are more transparent. So that obviously runs off the right side of the screen. So let's go ahead and make our subtitle element text box simple. So we'll do plot.subtitle element text box simple. And so I'm going to make that font a little bit smaller, and we're going to put a margin underneath it. And so in here, we'll do size equals 8. And then let's also do a margin. I'm mostly interested in the bottom being like 10. Oh, it's upset with me because I forgot to say margin equals margin. I think that's good. And maybe plotting symbol colored by the number of electoral votes. Maybe a number of electoral votes, I'll make that green color. And I can do that here with a span, and I can inject some CSS. So I'll say style equals color, and I probably should use a single quote, color that, and then we use dark green. So I'll do dark green, and then number of electoral votes, and then we'll close out that span. And it's kind of faint, so maybe let's make it bolded. What happens if we put 2 stars around it? So that's bolded. Cool. Battleground states, maybe make those also bolded. And maybe these I will span style color gold. And I put the stars around battleground states. Maybe I will put that star after a golden ring so that that golden doesn't get washed out. Span. It's kind of hard to read. Anyway, I just kind of want to highlight what we can do. So finally, let's turn our attention to these axis labels, because I think we've used up basically all the space around the plot now, and now we know how this is going to fit, if you will. Let's try that -30 to 45. So let's come back up here to this scale, and let's do -30 to 45 by 15s. And so this will be 30, 15, 15, 30, and then we'll do Trump plus 45. Oh, it's upset. Why are you upset? I must have forgotten a comma. All right. I think that's great. All right, now let's do it for the y-axis. All right, so we can basically copy this down for y. That kind of looks weird. Don't you think? Yeah, I feel like that looks kind of weird. But maybe not. Maybe we can move the title of the axis in so it's not just sticking out so far. The other thing is we need to change the font color to be actual black. So we'll do axis.text equals element text color equals black, and put this on a separate line. Okay, not big a change there. And so then our Y title, we want to move to the right. And so I think we can do this with a margin. So we can do axis.title.y equals margin, and then it's the right margin I think that we want to do. So let's do R minus 20. And it's yelling at me because this needs to be an element text. I'm getting tired if you can't tell. Axis title Y, vectorized input to element text is not officially, I am getting tired. So let's do margin equals that. And if you can detect my problems before I do, you're doing a good job. So, and if you can't, that's fine. We all learn together. So that's good, but I don't think I quite want it in so far. So let's go back to minus 15, and I think that looks pretty good. So as I look at this, I can't help myself but to want to keep picking at this. And I think what I'm going to do actually is remove the Harris and Trump. I also don't need +0, that doesn't make any sense. But the Trump values, I'm going to make red, and the Harris values I'm going to make blue, and then in the title, I can put Trump and Harris. What do you think? All right, let's give that a shot. And then perhaps we can get rid of this margin on the axis title Y. Anyway, so let's come back up here. And again, we don't need that +0. And I don't think we need the Harris. So we'll move that. Or the Trump. And what we're going to do is for the labels, we'll do span style equals color semicolon, and then this is going to be Harris, right? So this is going to be blue, and then we'll back out of that, right? And so we'll repeat this for this +15, and then let's see what it looks like. So we'll do 15 there. And so this then is going to be element markdown on the axis text X. So we have axis text. So let's go ahead and make this element markdown. We're going to remove that color because we're putting in our own color. Very good. We now have the blue. Maybe I'll make it bold. And so let's do that. Element markdown. We'll do face equals bold. So that gives it some more gravitas. Also, this margin on the title can go away. I'll go ahead and just delete all that. All right. And so now we need to repeat this but with the Trump. And actually, we could probably get that 0 to be black by putting in 0, making the color black. And so now let's go ahead and repeat this for the Trump reds for the 15, 30, and 45. So we'll do red 15, 30, 45. So let's go ahead and do that. And 45. And we have the plus Democrat, the plus Republican. We can now transfer that up to scale Y continuous. All right. That looks good. And then perhaps in the title, we can make Trump red and Harris blue. So let's go ahead and do that. I'm going to grab this span so I don't have to retype all that stuff for Trump and Harris. And so then our first one, Trump, will be red and Harris will be blue. And we need to then render it with Markdown. And we did that with element text box simple for the subtitle. So let's go ahead and do that for the title. And so we'll go ahead and take element text box simple and replace that for the element text we had before for plot title. Good. Might be good to have a margin between the subtitle and the title. And so we can do that. Maybe with the subtitle, we'll do t equals 15. That's too much. Let's do t equals 5. I think that looks pretty good. So at this point, I think I'm making this plot way too ornate and probably overly difficult to interpret. The last thing I want to do, and honest, this will be the last thing I do, is maybe in the bottom right corner to say Trump outperformed polls, and up here to say that Harris outperformed polls. And then we'll call that a day. All right, so let's come up here then, and maybe before my scales, I'll do an annotation, and we'll do the geom. This is the first thing that goes, and we'll say text, and then we'll say x equals 30, y equals 45, and I'm realizing that I put 30, but that's really negative 30. And then our label will say Harris outperformed polls. Let's run that. Oh, and I put annotation rather than annotate. And we have it left justified. So let's go ahead and do hjust equals 0. Now that I look at it, I'm not totally thrilled with the way this looks. Maybe we can make it gray. So it's more subdue, right? So we'll do color equals gray. That's good. And then for Trump, so then for the lower right, let's make this a vector, and we'll make it basically the mirror of what we had. And then we'll do the same thing, but for Trump, right? And I screwed something up. I think, let's see. So I have 45 and that should be minus 30. So that gets it down, but needs to be over, maybe to like 15 or 30. What do you think? As I've gone along making this plot, it occurs to me that I have obviously a lot going on here, right? And that this plot is probably way too busy. I think by the end of it, we had 5 geoms. We had 5 aesthetics, right? We have actual polling size, age, electoral votes, color for battleground, right? So we have 3, 4, 5, 6. I don't know that I've ever made a plot with so many aesthetics. That is no doubt too many, right? And so, of course, we don't have the legend on here. And we're kind of having the legend in our subtitle here, right? And so, I don't know, to get fewer aesthetics, you have to make choices. You have to kill your darlings, as they say, right? And I didn't really want to do that. And as I kind of look through this, what sticks out to me is that 44 of 49 contests, Trump outperformed Harris. Actually, Trump outperformed Harris in the polls relative to the election. And so let's come in here. Trump outperformed the polls relative to Harris. So Trump obviously outperformed Harris, but that's really, he outperformed the polls relative to Harris, right? Like Trump could have lost and still outperformed the polls, right? But really what we're seeing here is that most of the points fall on the right side. So as I've kind of built this out, I've been thinking that like, maybe this visualization isn't the right visualization, right? I started with this index card of what I wanted to build today. And as I've gone through it, I've realized that this probably isn't the right plot, right? That perhaps what would have been better would have been some type of distribution plot where we would show how did Trump perform in the polls, outperform the polls, and how did Harris perform relative to the polls, and kind of show those distributions, right? So if I had to make another video and I had more time, I would, but I would probably do something like that. So again, what I want to drive home beyond making this plot is that as we're doing these designs, we can start with the best of intentions, but ultimately we kind of, we experiment and we kind of see how things look. So let me know what you think. If you had to kill your darlings to show this plot perhaps a little bit more clearly, by all means, let me know down below in the comments. I don't claim that this is a fantastic plot, that this is a plot that I would be ready to publish, but I think it shows a lot of good ideas. It shows a lot of concepts in using ggplot2 to generate a visualization. I like what we've done here with ggtext and putting in color into the text elements, as well as putting data in the title, as well as color in the title and the subtitle. I kind of do, now that I think about it, like the legends that I have here in the two different triangles of the plot. Let me know what you think. I'm going to call it a day. I could keep picking at this forever. And maybe what it comes down to is I think Nate Silver did a pretty good job of generating his visual that I showed you in the previous video. All right, we'll try something different next time. So that you don't miss that episode, please make sure that you've subscribed, and I'll see you again for another episode of Code Club.